Hi and welcome to this week's lesson from TheMathsTutor.ie for Leaving Cert Ordinary Level Maths. This week we're going to continue looking at statistics and we're going to be looking at inferential statistics. So inferential statistics is where we're going to take data and from a sample and we're going to try and use it to infer something about an entire population. So an entire population is everything that it could be, so everyone in a population or everything in a population. And when we're carrying out surveys, we normally only take a sample of that population. So when we get our statistics, we want to see, can we make some guesses about the entire population using the statistics that we have found. So as always, there's lots of resources up on TheMathsTutor.ie for all the full members, and we make a couple of those available each week. So the first one is going to be a video regarding the margin of error. So we'll be talking about the margin of error shortly, but this video will go into a little bit more detail about how to find the margin of error and how to use the margin of error to calculate a sample size. The second video is a worked example from the papers. So this is 2015 paper 2, question 6. Okay, so to start with, we're going to see what type of questions come up on inferential statistics. So when we're talking about inferential statistics, there's going to be a couple of new terms that we're going to come across, like margin of error, 95% confidence interval, sample proportions, population proportions, and hypothesis testing. And these are all going to get symbols, and we need to understand what those symbols mean and how we can use those symbols. So the first thing here says, an example, 150 people were surveyed about their favourite brand. So this could be a brand of anything or about their opinions on things. And we're going to get a proportion. So in this, it says 35% said they preferred brand A. So when we have 35% saying they preferred brand A, that's our sample proportion. So this 35% here is going to be our sample proportion. Because it's the amount out of the sample that gave a certain opinion or selected a certain answer or something like that. And this gets a symbol and it's called p hat. So p hat has this little arrow on top of it, and that's going to be the sample proportion. We're going to try and infer something about the population proportion. So the population proportion gets the symbol p. So this is P without the little hat on it, refers to the population. So from this survey, we have 35% saying they preferred something, and we want to see, can we make a guess about how many people in the whole population would agree with that? So the first thing that we're going to look at then is the margin of error. So the margin of error is how wrong we think this answer might be. So we're saying 35% here in this example, but we know that there's going to be a little bit of error built into that percentage, and it may not be exactly 35%. So how we calculate the margin of error is we say that E, the margin of error, is equal to 1 over the square root of n, where n is the sample size. So in this case here, I'm going to say n is equal to 150. So the error is going to be 1 over the square root of 150. And we can get that either as a decimal or as a percentage. So as a decimal, that gives me 0.0186. But oftentimes we're going to convert these to percentages. So just have a careful read of the question, because this question here, our example, had a 35% in it. I'm going to convert that to a percentage. So to convert decimals to a percentage, I'm going to multiply by 100, and that gives me 8.16% error. So what this margin of error tells me is that we've said from this survey that there were 35% who preferred brand A, but we now think that there's a little bit of wiggle room there, up to 8.16% either side of that 35%. The bigger the sample size, the smaller the margin of error is going to be. So the bigger n is, the smaller the error. So if we wanted to have a question, or if there was a question about how could we reduce the error, we could say increase the sample size. So that's going to give us less error in it. So now that we've said that this 35%, we now have this margin of error of 8.16%, that's going to bring us onto a 95% confidence interval. So when we have an interval, it goes from one number to another number. So we're going to see a range of numbers here from one number up to another number. And the 95% confidence interval, where the 95% comes from, is if this survey was carried out 100 times, 95 out of 100 times, we would get an answer in this range. Okay, so that's what our 95% confidence interval means. We're 95% confident of getting an answer in this range in 95 out of 100 times of carrying out a sample of the same size. So to generate a 95% confidence interval, the formula goes p hat minus e is less than p is less than p hat plus e. Now that looks a little bit complicated to start with, but all that we're trying to say here is that the sample proportion, so this part here is the sample proportion, p hat, is going to give us a guide to the true population proportion, which we've said is p. So there's our population proportion in the middle, and we're now going to be saying our population proportion is going to be between these two numbers using our sample proportion p hat. So our p hat was 35%, and we're going to subtract our 8.16%, which we'll say is less than the true population proportion, which is less than the sample proportion plus 8.16%. And that gives us a range from 26.84% is less than P up to 43.16%. So what this is telling us is that if we carried out a similar survey 100 times, 95 times, those answers for p hat is going to be somewhere in between 26.84 and 43.16%. And that's a good indication of the true population proportion is going to be in here somewhere. So we're inferring something about the population using our sample statistics. You can also write that as an interval using brackets. So you could write this as 26.84, 43.16%. And just if you're writing it using that method, make sure to use square brackets, because the square brackets mean including those figures. Now I'm going to use it as a confidence interval using my inequality symbols, but either answer is absolutely fine for your final answer with a 95% confidence interval. What we're going to use that 95% confidence interval for then is something called hypothesis testing. And when we're dealing with hypothesis testing, a hypothesis is basically a guess. So someone will make a prediction or a guess, and we're going to test out statistically whether that guess is a good guess or not. And when we're dealing with hypothesis testing, we have two types of hypothesis. So we have what's called the null hypothesis, and this gets the symbol H0. And we have called the alternate hypothesis, which is called H1. So the alternate hypothesis or alternative hypothesis is just going to be the opposite of the null hypothesis. So when we're writing these, the null hypothesis means that nothing has changed. Whereas the alternate or alternative hypothesis means that something has changed. So we're looking at whether our proportions are going to change. So in this example that we're looking at here, the survey said that 35% of people preferred brand A. So the null hypothesis would be H0, P is equal to 35%. And the alternate hypothesis, H1, would be P is not equal to 35%. Now, someone else might make a claim about a different percentage, and that could be our null hypothesis and our alternate hypothesis, and that would be what we would be going to investigate, and we'll see that in a couple of questions shortly. You can write out the null hypothesis and the alternate hypothesis using words, but I tend to use symbols rather than words. It's just shorter and easier to do, I think. So I would just say P is equal to 35% and P is not equal to 35%, but you can write that in words that the proportion is equal to 35% and the proportion is not equal to 35%. When you carry out a hypothesis testing, you have to make a conclusion. And your conclusion is either going to be that you reject the null hypothesis or fail to reject the null hypothesis. And this means that we're not using the word except, because with statistics, we leave this sort of error there. So we're not going to say it has definitely changed, but what we're looking at is that we're saying either we're going to reject the null hypothesis, so it appears that something has changed, or we're going to fail to reject the null hypothesis. It seems like it hasn't changed. So we're going to look at a couple of these things in detail now and a couple of questions from the papers, but just to have a look at what letters we've come across. Our P is our population proportion. Our P hat is our sample proportion. Our error is E, and it has the formula 1 over the square root of n. And then we'll have our 95% confidence interval by subtracting and adding that error to our sample proportion to give us an estimate of the population proportion. And then to use our hypothesis testing, we're going to have H0 and H1. Sometimes people use HA, and that's absolutely acceptable as well for your alternate hypothesis. So we're going to look at a couple of questions from the papers. So the first question here is 2021, paper 2, question 7, part B. So when we look at this question, it starts with, prior to the COVID-19 pandemic, Netflix held the largest share of the online streaming market with 65% of all streaming subscribers in the 15 to 65 age group. Aidan thought that this percentage might have changed during the pandemic and surveyed a sample of subscribers in this age group to get data. He then carried out a hypothesis test to test his theory. Okay, so the first thing that we're spotting in this question is that we have a 65% here, and that's how many people had this subscription to Netflix before the pandemic started. And what we're going to be investigating with this hypothesis test is whether or not that has now changed. So in Aidan's survey, 540 people responded to his survey. So we're going to mark this here. That's going to be our N. So N is our sample size, 540 people. So the first question is, calculate the margin of error of his survey and give your answer as a percentage correct to 1 decimal place. So to calculate the margin of error, we need our formula. So E is equal to 1 over the square root of n, where n is going to be our sample size. So E is going to be 1 over the square root of 450, as that was our, 540, as that was our sample size. So 1 over the square root of 540 will give me an answer of 0.043, and to change it to a percentage, we're going to multiply by 100. So when we multiply by 100, we're going to get 4.3%, and that's to 1 decimal place. So I'm rounding that off there to get to 1 decimal place. When I take out my calculator and do 1 divided by the square root of 540, I get 0.0430. So I know that I'm going to be rounding off to 1 decimal place. So 4.3% when I change it to a percentage. If it hadn't told me to change to a percentage, because this sample up here has 65% in it, I would have changed it to a percentage anyway to make these match rather than as decimals. But your proportion can be given as a decimal or as a fraction or as a percentage. Okay. So part 2 says his survey revealed that 372 of the responders said they now have a Netflix account. Use your answer to B part 1 above to create a 95% confidence interval for the percentage of the population that have a Netflix account. Okay, so we want to create a 95% confidence interval. So that's what they're asking us to do in this part. And we know that a 95% confidence interval comes from P hat minus E is less than P hat plus E. So to use our 95% confidence interval, we're going to need two things. We're going to need the margin of error E, so we've calculated that in part 1, and we're also going to need the sample proportion P hat. So we're going to have to calculate the sample proportion P hat before we can make our 95% confidence interval. So to calculate our sample proportion, we're looking at how many people he surveyed, which was 540, and we're going to look at how many of those respondents said that they had a Netflix account. So that's 372. So in this case here, our P hat is going to be equal to 372 divided by 540. And that's a proportion given as a fraction, but we want to convert this to a percentage because our samples so far, so our answer here and our answer that was given of 65% are both going to be percentages. So we're going to convert that to a percentage by multiplying by 100. And when we multiply that by 100, we're going to get 68.8 recurring. Now, it didn't say what to round this off to, but because this part here was rounded to 1 decimal place, I'm going to round this to 1 decimal place as well. So the little dot there on top of this 8 tells me that that 8 keeps going, so it's 68.88888. So when I round that to 1 decimal place, P hat becomes 68.9%. So now that we have our P hat, we're going to be able to fill in our 95% confidence interval and make an assumption or make a prediction about our population proportion. So 65% belongs to the population, everyone who has signed up for these Netflix subscriptions in the age of 15 to 65, whereas the 68.9 is only from the sample that Aidan has carried out. So to get our 95% confidence interval, we'll fill into this formula here. So we're going to say 68.9% minus 4.3% is less than the population proportion, which is less than 68.9% plus the error, which is 4.3%. And when we do that, we get 64.6% is less than P is less than 73.2%. So that's our 95% confidence interval. So if we carried out 100 surveys, we would expect to get an answer 95 of those 100 or 95% of those answers will give us an answer in this range. So then we have to carry out our hypothesis test. So now that we've worked out our margin of error, which allowed us to calculate our confidence interval, we're going to use our confidence interval to conduct our hypothesis test. When they describe our hypothesis test here, in part 2, we have something called a 95% confidence interval, but in part 3, it says at the 5% level of significance. Now, this just means that our 95% confidence interval plus the 5% level of significance add up to give us 100%. And this comes from our empirical rule that we looked at before, and our empirical rule said that 95% of the data was in here, which means that 5% of the data is outside. So on this piece here and this piece here, we have 5% of the data. So that makes that significant. It makes it quite different to all the other data, and that's just where that 5% level of significance comes from. We don't have to do anything different to our 95% confidence interval. It's just how they word it. So we're going to use our 95% confidence interval to carry out our hypothesis test. So we have to state clearly your null hypothesis. So it tells us in the question, state clearly your null hypothesis, your alternative hypothesis, and give your conclusion. So we'll start by laying out what our hypotheses are. So H0, our null hypothesis, is that nothing has changed. So the proportion from the population in the age of 15 to 65 who have a Netflix subscription is going to stay at 65%. Whereas the alternative hypothesis, H1 is that that proportion has changed. So it's now not equal to 65%. And how we carry out our hypothesis test is that we're going to look at this figure here, so our 65%, and we're going to look at our our confidence interval, which was from 64.6% up to 73.2%. And since the 65% that was given to us is in this interval goes from 64.6 up to 73.2, and 65% is in that confidence interval. So that means that it may not have changed. It appears that the 65% could still be the right answer because it's in that confidence interval. So 65% is in the confidence interval, so we're going to fail to reject H0. So we're saying, yep, this 65% is still looking good. We're going to fail to reject H0, and we have to make a conclusion in the context of the question. So that means here that the percentage of subscribers to Netflix in this age group has not changed. So Aidan thought that it might have changed, but when we carry out this hypothesis test, it appears that it hasn't changed, because when we get this confidence interval, our 65% is still in that interval, so it looks like it hasn't changed. Okay, so that's when we get a answer that is in the confidence interval. Let's see what happens when we carry out a hypothesis test and it's not in the confidence interval. So the next question we're going to look at is 2020 paper 2 question 3. So you can see these can be part of your section A questions or your section B questions. So in this question, in a survey, 1,000 people are selected at random. So there's our N is equal to 1,000. How many people are in the sample, or what is the sample size? And ask some questions about online shopping. Find the margin of error of the survey and give your answer as a percentage correct to 1 decimal place. So there's a couple of things they're asking us to do here. Just like in the last question, we're going to start by finding the margin of error. So our formula for the margin of error is 1 over the square root of n. And our n we've said is 1,000. So our error here is going to be 1 over the square root of 1,000. And when we put that into our calculator, we're going to get 0.031622 and so on. Now we want to convert this to a percentage. So to convert a fraction or a decimal to a percentage, we're going to multiply by 100. And you can of course multiply the fraction by 100 on your calculator straight away. And I'll get 3.1622. So I'm going to round this off. So the 6 says to round up the 1, so I get 3.2%. So the margin of error for this survey is going to be 3.2%. Of those asked, so in part 2, of those asked, 762 said they believe it is safe to give their credit card details when shopping online. Use your answer to part A, part 1 above to create a 95% confidence interval for the percentage of people who believe it is safe to give their credit card details when shopping online. So we're getting another 95% confidence interval. So to remind us of this formula, that's P hat minus E is less than P is less than P hat plus E. So again, we've calculated E in part 1, so we're going to have to calculate our sample proportion P hat. So we were told that 762 people, and we know that that was out of 1,000, so that's our sample proportion, 762 out of 1,000. Again, it doesn't tell us what to do with this. Do we leave it as a fraction or a decimal or a percentage? But because our margin of error was a percentage to 1 decimal place, we're going to do the same thing here with our P. So our p hat, when I change that to a percentage, is going to be 76.2%. So to make our 95% confidence interval, we'll take our p hat and subtract our error is less than our population proportion is less than our p hat plus our sample error. And that gives us a confidence interval from 73% up to 79.4%. So our confidence interval here goes from 73% up to 79.4%, and we're going to look at a hypothesis test using this confidence interval. So an online media company claims that 80% of people believe it is safe to give their credit card details when shopping online. So this is the claim here that 80% say it's safe. Conduct a hypothesis test at the 5% level of significance to test the company's claim. So again, this is saying at a 5% level of significance, which just means use your 95% confidence interval. And it will always be use your 95% confidence interval when you're carrying out a hypothesis test. Give your conclusion in the context of the question and give a reason for your conclusion. Now, this question didn't say we specifically had to set out what our H0 and our H1 are, but we're going to do that. So H0, our null hypothesis is that nothing has changed. So we'd be saying, okay, so P is 80%, whereas our alternate hypothesis, P1, is that P is not equal to 80%. Okay, so this is their claim, and we're going to see, does their claim lie in our confidence interval? Now, it asks for the conclusion first and then the reason, but I'm going to explain my reason first and then go back to my conclusion. So what I see here is I'm going to check, is 80% this claim inside my confidence interval from 73% to 79.4%? So 80% is not in my confidence interval. So this confidence interval only goes up as far as 79.4%, and 80% is greater than this interval. So that means that 80% is not in there. So I'm going to reject the null hypothesis this time. So because it's outside that region, we're going to reject the null hypothesis, and that means that this 80% doesn't appear to be true. So we're going to give a conclusion in the context of this question. So we're going to say the percentage of people who believe it is safe to give their credit card details when shopping online is not 80%. And that's how we deal with it when the claim is outside the confidence interval. So hopefully this lesson has given you a little bit of help with inferential statistics. And don't forget that there's 2 videos available there in the comments. One of them dealing with margin of error a little bit more and how to calculate n. So if I was given a margin of error, could I work out the sample size? And another worked example from 2015, paper 2, question 6. Thanks.